Hi guys, Mr. NW Chidi again here. Today, we're talking about the bouncing ball. Remember, last time on my last topic, I said the ball moved from here and the ball went up, it came back here, then it passed its starting point straight to the ground. Now, what happens when the ball gets here? Remember, here we had a negative velocity when the ball was going up because we are taking our downward positive. Now, when the ball leaves here, then V is negative because the ball is going up. And we know that when it is here, V is positive. But here, it is the turning point where V is equal to 0. And then acceleration, here we say that it will always be 9.8 meters per second as long as you are taking downward as positive. Now, look, when this ball passes this point, let's say this building is 80 meters, and then it goes to the ground. When it gets here and it bounces off the ground, what happens here? If it had a initial velocity from here, because this is point A, point B, point C, and point D. Now, this ball from here to here, it had an initial velocity, which was this one, the final velocity when it was coming from the turning point to here. So from here to here, you have two velocities, which is here when it leaves, now we call it VI because it is leaving point C. Now it goes to point D, and at point D here you have velocity F at point D. And this velocity, this one, is when the ball hits the ground. Now, what happens here? The ball now changes direction. The ball hits the ground and bounces off of the ground. Now, how will change in momentum of this ball? Here the ball collides with the ground. And immediately while like a collision, topic in momentum. Where now you are going to apply momentum. And then result momentum, your change in momentum P is equal to mvf minus vi. Now, what is this vi now? And what is this vf? Now, the vi now becomes what? The velocity when the ball hits the ground. Velocity when the ball hits the ground. And that is your velocity before collision. Now, what is this one? The VF. Your final velocity will be the velocity at which the ball bounces from the ground. That is V after collision. Now be careful, because now re mo re bolela ka momentum jwale, and re tseba straight gore as long as re bolela ka momentum and we know a change in momentum of this ball, because it was going down, it hits or collides with the ground, and now it changes direction and goes up. Now velocity, the final velocity will now be what? Negative, but the initial velocity will be positive, because initially the ball was going down, and then after the bounce it is going up. Now you are going to have m into negative vf, because now the final velocity is when the ball bounces off, which is your vf, minus then your initial velocity vi, because initial velocity is positive because it was going down. Then this is just the negative from the formula. Now, what else can we learn from this scenario? We know that we have also what? When the ball bounces here, it has a contact with the ground. We have a contact time. Now, it means that we can now talk about the impulse, which is equal to change in P. And we know our impulse is the product of the F net multiplied by the contact time is equal to change in P, the momentum. Then this one is the contact time. The time at which this ball is in contact with the ground before it bounces. So when it hits the ground, let the ground, after some time, it bounces off. Now, this one is your F net, the force at which the ball exerts on the ground. Force at which the ball exerts on the ground. And the ground also exerts the same force on the ball, which is equal to the force at which the ground exerts on the ball. Now, collision, the ball is colliding with the ground. Topic momentum. What is the last that we want to talk about? The last, we know that the ball here, as long as it was in contact, then it lost some energy. Now we know that here the energy was lost. So if you want to check how much energy was lost here when the ball was changing momentum, then you calculate what? Change in EK, which is 1 over 2 mvf squared minus 1 over 2 mvi squared. And the same, the initial velocity is the velocity at which it hits the ground, and the final velocity is the velocity at which the ball bounces. Then you can find what? You can find the change, the energy lost here. All right, now this will be your mass in kilograms. Now, as long as a bouncing ball, please apply momentum here. Please always apply momentum here. And your initial velocity is before the collision, which is the velocity at which this ball hits the ground. And the final velocity is the velocity after the bounce. Now, in my next lesson, I'll do one example of this type of a question. Then, how do we apply? Then, move the hot air balloon. So, keep on subscribing, keep on sharing the link, be in touch so that we grow and we learn and we teach each other. And also comment if there's any help that you need, then so that I can explain whatever that you want to understand on my next video, or whenever I post a next video. Thank you guys. I'm still your guy, Mr. NW Chidi. Please subscribe and grow this channel. Thank you.